And at this time, I would like to introduce Ken Burns, the chair of our Science Curriculum Committee, who will give us an introduction to this special presentation. Thank you.
Good afternoon. It's my pleasure to welcome Dr. Englander today. He's a special guest, and he's going to talk about something that, from the science point of view, at some levels, I think is accepted science, although not everybody might agree with some of that. But I think this is a really important topic. And for those of us that live in Florida, it has particular resonance, although we're not quite in the same situation as those in Miami and the areas around there. But anyway, the person who did a lot of work in getting this afternoon's lecture in place is Alice, and she's going to do the actual introduction of Dr. Englander. Thank you.
Well, thank you, Ken. And thanks to all of you who have come this afternoon and also those that are on Zoom. Really appreciate it. And a special thank you to Julianne, who is here as a volunteer today. So where are we with climate crisis? Because of procrastination and delayed action, seas are rising, land is subsiding, and we are passing the tipping point. So a lot of folks are talking about it, but what sets our speaker, John Englander, apart is he has seen it firsthand on explorations to the Arctic and to the Antarctic with the military. His degrees in geology and economics, his background in marine science, his experience as an oceanographer and as CEO of the International Seakeepers Society and of the Jacques Cousteau Society, and the leadership of 2 expeditions under the polar ice cap, all give him a broad picture of what is underway. He currently is CEO of the Rising Seas Institute, focusing on the impacts and, more critically, how to prepare. John's first book, High Tide on Main Street, was published in 2012. That book, he predicted a number of scenarios, one of which was New York City if a hurricane hit from the southeast. 1 week later, Hurricane Sandy hit New York, and it was devastating. In the course of 48 hours, it destroyed 300 homes, caused 44 deaths, an estimated $19 billion in damage and lost economic activity, and over 69,000 residential units were damaged. Needless to say, his first book became a bestseller. His latest book, Moving to Higher Ground, points out the intensity of storms, droughts, and fires are increasing as the ice sheets melt at an astonishing speed. So how did I get involved? For over 2 decades, we lived on a canal near the Intercoastal Waterway, about a mile from the inlet. Our original dock was 2 levels that accommodated the constantly shifting height of the tides. The dock needed to be replaced. And as I looked down the canal, I saw that no one was putting in the lower dock. Now that's only a difference of about 4 or 5 inches. But when you're sitting in a house that's only 8 feet above sea level, you start to really notice. It's one of the reasons Bob and I decided to move to Gainesville. So as John says in his latest book, Moving to Higher Ground, we have no time to waste. With that in mind, it's my pleasure to introduce John Englander, live from Boca Raton.
Thanks, Alice and Ken and Julie. Alice, you've been a longtime supporter of my work, and it's a pleasure to, in particular, to do this program for your community there at Oak-Hammock and the ILR program. As you've well described, my journey has been very focused on sea level rise since my first book came out in 2012, and you did a great job describing the coincidence that the book came out on October 22nd, 2012, and a week later, a superstorm hit Atlantic City in New York, a scenario that was described in the book. Frankly, that was a coincidence. It was luck in the sense, bad luck for all the residents that were devastated in Manhattan and the surrounding areas. It was a lucky timing in terms of giving my book notoriety. But we need to look objectively and without, setting aside the issues of coincidence and luck, and understand how this planet's changing. So, we've seen photos of space of our planet since 1968, and it helps us to see the world and the changing cloud patterns. But we've always assumed that while the land areas might go from brown to green or green to brown, depending upon vegetation, we assumed that the landforms were constant, that there was not going to be a significant change in the ocean land boundary, except for some odd bits of erosion on the coasts. But given the facts of global warming, climate change, which I'm going to talk about, the fact is that the Earth is going to start looking different, because literally the coastlines are going to change. Not so much year to year, but over the next few decades, by mid-century, and I'll talk about the longer time horizon and what's happened in the past. Because the truth is, until the threat of climate change and the challenge of what the science community is now telling us, we didn't really contemplate sea level changing much. And this is a really fundamental new concept that's not well understood. So I really appreciate those of you in Gainesville, either online or in the room there, taking the time and interest to get educated about this, with the hopes that you teach others, as is my kind of the outcome of my work, that to find people who will carry the message elsewhere. We think of a variety of green or environmental issues, just shown by a circle here, and climate change can be seen as kind of a subset of environmental and green issues. I point that out because we're not talking about the entire range of environmental issues. We're not talking about fish species and coral reefs and manatees and any sea turtles, lots of things that we might all consider part of the environment or green issues. And even within climate change, while it's commonly described as the climate change problem, I would like to suggest that you think of it as three different problems. The climate change problem, the focus that most people have today is, how do we slow the warming? How do we make sufficient energy without increasing the greenhouse gases, abbreviated there as GHG, particularly carbon dioxide? How do we reduce the levels of carbon dioxide or greenhouse gases in the atmosphere? And I'll talk about this a little bit, but that aspect of climate change, the question of how to slow the warming and the issue of the current warming due to increasing greenhouse gas emissions from burning fossil fuels, is represented here by that black circle. And it's extremely important. It's where most of the effort is currently going, and rightly so. The orange circle lists a number of effects of climate change, very different from the question of the energy issues and how we're going to produce sufficient energy for the world's people without further warming the planet. And the effects include effects on our water supply. We're either getting droughts or we're getting too much rainfall. We're getting strange weather patterns. We're getting high temperatures. We're getting ecological impacts, different diseases, arguably even the COVID, and effects on our food supply. So lots of effects from climate change that we need to begin to cope with. Sea level rise could be seen as one of those effects, but my case is that it's quite unique because it's going to change the coastline. It's going to put areas permanently underwater and has a profound economic impact as well as an environmental impact. In other words, as millions of acres and trillions of dollars of coastal real estate goes underwater, which I'm going to describe, that has a category of its own because of its permanence and because it goes beyond what we think of as normal short-term weather impacts, and even heavy rainfall, which can turn into drought in the same location from one year to another. Sea level rise is different, is the case I'll make, because it depends upon the polar ice caps, which I'm going to show you in just a moment. So to me, it's a special category of climate change. Climate change we talk about as the climate change problem. It's really three problems: how to slow the warming and make sufficient energy, how to deal with the effects we're getting in the near term, in the next year or two, and then how to prepare for an effect which is just starting in the earliest stages, rising sea level. Here's Florida, as you can perhaps see in this satellite image. And of course, front and center is Grand Bahama Island, slightly off the coast here, a place that I lived for more than 25 years. I know it well. And it just happens to show a hurricane going over. I think this was Hurricane Matthew, which kind of stalled on Grand Bahama after having wiped out large parts of Abaco, another Bahama island further east, and shown there. I like to start with this because it's the start of my interest in this topic. 50 years ago, I was diving off Grand Bahama, and I described this in my books, that I was 200 feet below the surface, straight down, doing a deep dive with a group of people. And I saw a bunch of little shelves of looked like miniature beaches in the simplest terms, sand and seashells and things like that. And they were all along the shoreline, 200 feet below the surface. And being a geology major at the time, as part of my oceanographic training, I was trying to think what would have caused that. And it suddenly hit me. That could be when sea level was down that low. And with a little bit of further research back at school the next year, indeed, we determined that's exactly what it was. That 11,000 years ago, sea level was 200 feet lower. And the place I was diving at that point, 200 feet below the surface, was at that time the surface of the ocean. So it had a really profound effect on me, and really a thought I couldn't get out of my head over the coming decades. Still never thought it would change in my lifetime. I thought sea level was so slow changing that it wouldn't change much in centuries, because in geologic time, that's normally what happened. So I'll come back to that in a minute. But first, to put the question about what about Florida, since that's where we live, but I'm also going to look at this globally in a moment. But the red area on Florida here shows at 1 meter, and a meter is 3 feet, 39 inches, but just call it 3 feet for simple sake. A meter of sea level rise, 3 feet, will put about 10% of Florida underwater. That would be about 1.5 million people displaced. $130 billion estimated property loss. Now, in terms of the impact on the economy, if that were to, when that happens, it will be even more profound, because there will be lots of indirect effects on local economies if that much of Florida was submerged. But it's just one way of looking at things, in a little detail. Gainesville, of course, near the top of the screen, where you all live, is 150 feet above sea level. You're high and dry. It will take probably thousands of years, for even at the current rate, for enough ice to melt to raise sea level so that Gainesville were threatened. So from that standpoint, as Alice said, she moved from Boca Raton here on the coast. I still live in Boca. My house is over 10 feet above sea level. It's not in any imminent danger of flooding, but trying to be realistic once you understand the forces of sea level rise, and set aside the nonsense and misinformation and politics, and really try and look at what's happening to this world, so that both for our lifetimes, but our kids or grandkids or nieces or nephews, or just future generations, we need to understand this. And I appreciate your taking the time and interest to do that. Coastal flooding should be thought of as several different things. We have storms, heavy rain, and runoff as the rain goes downhill and can multiply. But those are weather events: storms, rain, and runoff. they're temporary flooding. The water recedes eventually or dissipates and gets back to normal, and you can rebuild or pump the water out. Extreme tides are a regular pattern that's predictable, changes by location. It can be negligible near the equator. It can be nearly 50 feet daily up in the Bay of Fundy or places like that. But for most of the world, the tidal change twice a day nearly is about 3 feet, 2 or 3 feet. So we see flooding during extreme tides, and that's getting worse, as I'll show you in just a moment. Rising sea level is my main focus here, and it's only in the early stages. The difference is that rising sea level is slow and permanent. It's like a drip filling the bucket. But as sea level gets higher, and we don't notice it at the lower end, during the high tides or during the storm events, when there's extra water present in coastal areas, the flooding is even worse. So in effect, these first 5 categories combine, the difference being that the storms, rain, and runoff are weather-driven events. The tides are entirely predictable by time and location because of the position of the planets, notably the full moon or new moon high tides. And then the 6th item is erosion, and erosion is quite different. It's a natural process. It is would happen even without sea level rise during storms, and even without storms, coastal erosion is normal. So these 6 items are a way to think about different kinds of coastal flooding and avoid the confusion when people miscategorize what the cause of the problem is. As an example of how things are changing, this is Stranahan House in Fort Lauderdale. It's, I believe, the oldest house in Broward County. It's over 100 years old. When this house was in use 100 years ago, the dock didn't go underwater regularly. And they certainly would have designed it differently if the water normally got to this level. This is just indicative and just puts in historical perspective what's happening now. We're getting regular flooding even without stormy weather. You may see through the trees there, it's kind of a blue sky, but I'll show you this in a few more examples in a moment. Here's a street, and this could be, frankly, in any coastal area of the world, from Copenhagen to Hong Kong. But this happens to be Fort Lauderdale. There's a truck off to the right, a black truck you can see on the right-hand side. There's some boats in the background in a canal, but this is a street. That's where the barricade is, marking a pothole. That red and white sign says no wake. Normally we see those in boating areas so that boats don't drive so fast as to throw a wake. I'm sure you've all seen that in coastal areas. This no wake sign is on the street, and they erect it every time the salt water comes onto the street during an extreme high tide. That's to warn people not to drive their cars so fast and splash salt water on other people's cars, which rusts the cars, of course. As soon as the water dissipates, which usually happens in a couple of days after the tide cycle is at its maximum, people take the sign down, because not only is it just something you can hit with your car, but it suggests that there's flooding on the street. And if you're going to sell your house, you probably don't want to conjure up the image in people's mind that that street has flooding from the ocean or from the canal. But it's happening regularly. This happens many days a year now. So let's start with a reference point for climate change, or also known as global warming, which is even more descriptive, perhaps. The planet is already 1.2 degrees Celsius. That happens to be about 2.2 degrees Fahrenheit, warmer than it was 2 centuries ago when we started burning fossil fuels in huge quantities. We are on path for nearly triple that at the current rate of warming. That's led to all the conferences. You've perhaps heard in November, there was the COP conference, the Conference of the Parties, and the part of the United Nations program, the Intergovernmental Panel on Climate Change. All of these things get in the news because they've been warning us for 26 years that we need to slow the warming. They've established that the target is to try and slow the warming to 1.5. And if we can't get that at least to 2 degrees of warming, But to put this in reference, again, we've already warmed, and this is in Celsius, and I know that's hard for Americans because we don't use that normally, so I'll translate that. So we've already had 1.2 degrees Celsius, which is 2.2 degrees Fahrenheit, and we're trying to keep it to 1.5 degrees or 2 degrees Celsius. That's about another 3 degrees Fahrenheit of increase. We're failing at the goal. We continue to warm, even with the switch to some electric cars and solar panels. We are warming more each year. But in fact, if we just step back and look at something here, the planet's already warmed over the last 200 years, 1.2 degrees. The scientific community says we should try and keep the warming to 1.5 if we possibly can, although it will take such effort to stop the warming and get the maximum to 1.5 or 2 degrees that they're not sure we can do it any longer. As you may have seen reports, scientific reports to say we may be too late to stop that, having procrastinated it getting off fossil fuels this long. But even if we could keep the warming to the ideal target of 1.5 degrees, that's 0.3 of a degree Celsius, about 0.5 degree Fahrenheit, warmer than we are now. The point of this is that even when you hear there's a goal to stop the warming over the next 20 or 30 years, or to get to zero emissions by the year 2030, 8 years from now, that's 30% more warming than we've already had. So the effects we're already seeing with the melting ice sheet, which I'm going to take you to see in just a moment, the effects of melting the ice sheet are going to be worse than they are now. There is no proposal to stop it where it is today. There's a lag time to affect warming and for the warming to slow the melting of the ice. So it's just kind of a big picture. The point is we have warmed the Earth considerably, and most of the heat is stored in the ocean. 93% of the excess heat is stored in the ocean. These temperatures I'm using here are not only global averages, they relate to ocean temperature, and oceans have a lot more temperature stability because it takes a lot more heat energy to warm the oceans, and it takes a lot longer time to cool the oceans. Think of an outdoor swimming pool. It takes a long time for that pool to come up to the outdoor temperature when it gets warmer in the summertime. And conversely, in the fall, an outdoor pool will retain its heat longer because water retains heat as a high heat value. Another reason we get confused is we hear about different temperatures in different places, and that can seem to be in contrast to the idea of global warming or this temperature increase. But just to show you this depiction, the blues and different shades of blue show where things are cooler than normal, and the reds where they're warmer than normal. And without getting any detail, the point is that in this particular date, that the northeastern United States and Canada and parts of the Arctic are colder than normal. They're dark blue. But there's, at the same moment, the same day, there's large areas that are much warmer. And this is what's happening as the patterns change. We may get a warm air mass that goes to the Arctic that displaces a cold air mass and comes further south. And suddenly we have abnormally cold temperatures in certain locations. And we think that contradicts global warming and the general warming that has been happening now for decades, but it's not. It's part of, when we see a bigger picture, we can see, oh yeah, up at the Arctic near the North Pole and in Greenland, it's much warmer than normal. And even if that's displaced a cold air mass further south, what they call a polar vortex, that doesn't in any way dispute that the Earth is warming. In fact, here's a graph just showing the last 40 years in effect of global average temperature. Again, you can pick a year or two or three and show that it's stable or even going down. But think of this like a stock market chart. I mean, you'd be glad to invest in this company because the trend is quite clear. It's consistently over time going up, and that's what's happening with temperature. So when we look at another image of the Earth from the one I started with, clearing away the clouds and giving us clarity, again, there's regions that have green and are both from trees and vegetation, and there's the brown areas for different reasons, different kinds of drought. And then there's the two white areas, Antarctica at the south, of course, and Greenland at the north, and a little bit of Canada as well is shown as white. And there's a few other bits of white, but they're small. Of the ice cover on the planet, which I want to take you to in a little more detail, 98% of the ice on land, and I'll show you why that's important, is in these two places, Antarctica and Greenland. The other 2% is from Alaska to the Alps to the Himalaya Mountains, holds 2% of the ice on land, so relatively insignificant. Now, I'm sure you've seen pictures of the melting Arctic, and there's been some concern about the habitat for the polar bear, and understandably so. As their habitat melts, it does pose a problem for the polar bears, and that's certainly an area of concern. But I'm going to again set that aside for today. I'm going to stay focused on understanding this larger trend of what's happening to our coastal lands all over the world. As the Arctic melts and goes from bright white to dark blue, it's like taking the roof of your house and changing it from white to dark blue or black, or vice versa, taking a dark roof and turning it white. It will change the heat reflectance. You know that. And a car is similar to a white car, is much cooler inside than a black car. You've also probably seen icebergs. And many people think that that's why sea level is rising as icebergs melt. But to use the kind of a pun of the famous slogan of just the tip of the iceberg, remember that about 10% of an iceberg is above the surface. 90% is below the surface. And although they're melting quickly, the melting of icebergs has no effect on sea level, really surprisingly. But if we think of a glass of water as shown here, it'll teach this to us. Ice cubes in a glass, if they're floating, if they're not touching the bottom of the glass, are floating about 10% above the surface, just like an iceberg. And if you just allow the ice cubes in a glass to melt, mark the level of liquid, let them melt, the level won't change. It's because ice is less dense than water, about 10%. That's why it sticks, think of it almost like a piece of wood that would largely float. And as ice melts, it compacts again into water being a little more dense. And so the excess part that's sticking out of the water, whether it be an ice cube in a glass or the iceberg floating in the ocean, effectively disappears, has no effect on the level of liquid. It's very surprising, but an interesting science point to teach people and challenge people with and get their interest, because it is counterintuitive. It's the ice on land, shown here in a glacier. You can begin to visualize that this glacier, which helps the ice on the top of Greenland get its way to the ocean, and it adds to sea level in two ways. When the glacier gets to the sea and breaks off into a new iceberg, that's like adding another ice cube to our virtual glass of water. That, of course, adds to the level of liquid. So ice on land that falls into the sea or moves into the sea does add to global sea level. Also, any melting that happens while the ice is on land, that melt water will kind of go underneath the glacier or perhaps run down on the surface. That melt water will add to sea level rise. And then there's a third phenomenon that adds to global sea level, which is thermal expansion of seawater. As the oceans warm, they expand slightly. So those three things, new ice added to the ocean, melt water from ice on land, and thermal expansion as the oceans warm, those three things create global sea level rise. There are other regional effects of land subsidence and uplift, changing currents and a few other things. But the big picture for sea level is the amount of ice on land. Now, to show you, Florida actually gives us a great insight into what happens with the changing natural levels of sea level as climate has changed in the past naturally. There was natural climate change, and that's surprising to a lot of people. So it's important to cover this. If you look at Florida's shape today, which everybody can recognize, and compare it to 20,000 years ago, sea level was then 400 feet lower. And Florida was nearly twice the size, particularly on the West Coast where we have that shallow bank. As many of you are familiar, I mean, you can't get beyond 50 or 100 feet water depth on the West Coast of Florida for many, many miles because of that shallow bank. So that was exposed, and it was all land 20,000 years ago. But 120,000 years ago, during the peak of the last ice age, or the last warm spot, sea level was 25 feet higher because more ice melted. And I'll show you that in a different depiction in a moment. But it's just vivid to see how Florida's shape has changed and the amount of land has changed. Now, I don't know if maybe you didn't see the kids' movies, or maybe watching with your grandkids and for some of you, but there was the 4-part Ice Age series. And this was the promotion from Ice Age Part 2, The Meltdown. And if you saw this, it was a funny little animated movie with these critters, and but behind them was the 2 miles of ice. It's actually quite realistic in terms of geologic history. And that 2 miles of ice, just think of it as 10,000 feet of ice on land. As those glaciers and ice sheets retreated, sea level rose about 400 feet. So, and that makes sense. And, a lot of times I think scientists make this too complicated and really don't communicate well with people. But this visual helps to make the case of how sea level changed. Here's a very simple diagram, again, trying to make this something that you don't have to be a scientist to understand this. But if we look back from 24,000 years ago, shown here on the left, to the present, shown on the right, we can see that sea level rose almost 400 feet, shown here as 390 feet. The rate of sea level rise over these 20,000 years roughly is not linear. It's not a smooth line. It's not even a smooth curve. Two things worth noting: the rate of sea level rise changed 3 times dramatically, shown by those blue arrows, and it got to the present level about 5,000 years ago. That's pretty much human civilization. That explains why we have trouble believing that sea level will change much, because for all of human civilization, it's been pretty stable. I'll show you this in further detail in a moment. But I do want to show you before we go elsewhere that if you look at this third arrow, back to my example from the Bahamas and seeing an ancient shoreline, that's when sea level was down 200 feet lower about 11,000 years ago, which was now is obvious to me, but I was struggling to put that case together back in 1972. But it's where the scientific analysis merges with what we know from geologic history. And this on the building on the right is just to show that. So we've had about 30 floors of an office building, if you would, of sea level rise since the last ice age. May seem like a long time ago, 20,000 years ago, but as I'm sure you know in Earth history, that's a blink of an eye. And if we melt all the remaining ice on the planet, it would be another 212 feet of sea level rise, or another 17 floors to the top of this building, just for scale and perspective. If we look at sea level since we've had human records, actually going back to tide gauges, the measured global sea level changes, which were fairly accurate, we can see that sea level has been rising for those 170 years. The lines, has some warbles, but again, think of it like a stock chart. I mean, you wouldn't really care about the warbles and the variations if you can see the big trend. And the trend here is quite clear. Sea level in the last century has risen about 8 or 10 inches, about 20 centimeters. When the rates changed a little bit, but the consistency actually is what should get our attention. This has been going on for a long time. If we look at, I'm sorry, let me back up. In the upper right, there's a satellite shown, and there's a red line. Since 1990, 2003, we've had much more precise measurements of global sea level from satellite measurements, doing satellite radar altimetry, bouncing radar signals down to measure the Earth from satellites, amazingly. And they were able to do it every day and a half. So we get the same technique and instruments, and we get real consistency now with the satellite measurements. If we look at just the satellite record, we can see how the rate of sea level rise is changing with far greater clarity. Starting in 1993, the rate had been about 1.5 millimeters a year. That's about 1/20 of an inch. Then starting in 2000 till today, the rate doubled, more than 3 millimeters a year. That's significant. And in just the last decade, the rate is almost 5 millimeters a year. So, without knowing any science, I mean, pretend this was an investment again, or any number, that to go from 1.5 to 3 to about 5 is showing an acceleration that is really ominous. I mean, if you think about compounding interest rates, anything above 10%, if you're making more than 10% a year, you're getting rich. And if you're borrowing money at more than 10% a year, you're going broke because of compounding of interest, as I'm sure you all recall. Well, we're seeing a compounding of rate of sea level rise here. So to pull all this together in a graph that's in my books, either of my books, but particularly the new one that Alice cited, Moving to Higher Ground, this shows 400,000 years. It's the first graph in the book. It's in page 11, actually. And it shows three things. In green is a greenhouse gas, carbon dioxide. Red is global average temperature, and blue is global mean sea level. So let me talk you through this, because there's really a lot of information in this one graph. And again, I encourage you to use it to teach others, which is really what I'm hoping comes out of today. Let's start with the red line. That shows 4 ice age cycles. Now, this has actually been going on for 2.5 million years, but we're just showing 400,000 years to show you a little more detail. But you can see it's a very regular pattern, about every 100,000 years. 4 peaks, 4 valleys, so 4 warm spots, 4 cold spots. We're pretty much at the warm spot of the natural ice age cycles. The ice age cycles are a phenomenon that's, again, been going on for 2.5 million years. It's driven by a change in the planet's the Earth orbit around the sun mostly. It's called the Milankovitch cycle. I explain it in very simple terms in the book, but I don't want to get distracted by that now. But the point is that we have had natural climate change. And people who say, well, it was warming before, and the ice ages and mini ice ages and medieval warm period, and how come there was concern 100 years ago that glaciers were expanding? Well, all of those things are true. They're part of the natural pattern of ice ages, which were driven by an orbital change. Think of it like a super summer and winter. When the planet's warmer, the ice sheets on land get smaller and sea level gets higher. So that's why the red and blue lines go together. Almost an exact image of each other, I think you can see. And when the planet's cooler, the ice sheets get bigger over centuries and thousands of years, and sea level will fall. That's why the red and blue lines go together. The green and red line have a little more complicated relationship. By the historical record, before humans were burning fossil fuels, carbon dioxide was changing as the Earth temperature changed. When the Earth changed in these ice age cycles, which I've been describing now for some time this afternoon, when the Earth's temperature changes with ice age cycles, when it's warmer, the oceans release carbon dioxide to the atmosphere. That's why it goes up. And conversely, it's true. When the Earth naturally goes into a cooling period, the oceans, by a simple principle of physics, absorb carbon dioxide out of the atmosphere. So that's why historically the red line precedes changes to the green line. But now what's happened is shown in the circle in the upper right, the dotted circle, or dashed circle, I guess it is, where CO2, carbon dioxide, is going straight upward. It's broken out of the natural pattern. The natural pattern of carbon dioxide in green shown there is 180 to 280 parts per million. and it's now about 420 parts per million, 50% higher than in millions of years. And that correlates with burning fossil fuels. That's been well documented. Even the oil companies today accept that. People may not want to believe it. They may want to just cast this off as being natural climate change. But I think you can see that we're in a new era, that there was a pattern between carbon dioxide, temperature, and sea level. It's been going on for 2.5 million years. We're showing 400,000 years here. The lines move in parallel. And the problem is now that the green line is shot upward like a rocket, going straight upward, and the temperature is following it as it would, because that carbon dioxide traps heat in the atmosphere. And as the planet's warmer and the ice is melting faster, the ice on land, sea level is starting to rise. But there's a lag time between carbon dioxide, temperature, ice, and sea level. The last point before we go to the next slide, and we're nearing the end here, we'll get to questions in a few minutes. The last time sea level was higher, as I showed with that Florida picture, it was 25 feet higher than present. You can see that here in the blue line with this little flag saying 25 feet. That's really important because, again, by nature, without human intervention, sea level was 25 feet higher. That's a further argument about why we need to start thinking differently about future sea level, in addition to the warming we're causing. As I said, up there in Gainesville, you're high and dry at 150 feet or so above sea level. There are a lot of different projections for sea level. This is a NOAA, the National Oceanic and Atmospheric Administration, the US agency that's most directly involved with monitoring and modeling sea level changes. And by their own charts, they're saying we could have anything from 2 to 8 feet of sea level rise this century. It depends on how warm the planet gets. And even if we know how warm the planet gets, it's hard to predict exactly how the 2 miles of ice on Antarctica and Greenland will melt. So I want to take you there to show you kind of the uncertainty. Again, a different image, but just reinforcing what I said earlier, showing the Earth. Most of the ice is in Antarctica. If Antarctica melted, sea level would be 186 feet higher. Staggering, hard to imagine. Greenland holds about 24 feet of sea level rise. As I mentioned earlier, it's 98% of the ice on land, and therefore 98% of the potential sea level rise is in these two ice sheets. Greenland is surprising. Just to show you it against the eastern United States here, from Florida up to Maine and east or westward to the Mississippi River, Greenland is a little bit bigger than the eastern United States, just here shown for comparison of size. It's covered by over a mile of ice today, covering 80% of the island. It's melting really fast. As Alice said, I lead fact-finding trips up there. This is with Senator Angus King and the Commandant of the U.S. Coast Guard, at that time, Admiral Paul Zukunft. And we were there in 2016, I think it was, but I've been back several times since. I'll be going back this August. It puts in clear visual focus what's happening. This is the top of the ice sheet. You can see some helicopters behind us there, but the meltwater rivers are just the pooling of water from the melting surface and then finding some place to get to the ocean. The icebergs there are enormous. In fact, these aren't even the biggest icebergs. But again, while they don't directly add to sea level, these big icebergs are being calved or spawned, to use the normal terms, because the warming of the ice sheet and the glaciers, which are moving faster, melting and breaking up. And it's when these giant icebergs enter the sea that sea level rises. Although for any one iceberg, even the largest, the effect on global sea level is imperceptible. But the amount of icebergs is increasing dramatically. So again, just to come back to that graph, hopefully it makes a little more sense now. The changing greenhouse gas levels shown in green, particularly carbon dioxide, that's what's mapped there, will cause temperature to warm for centuries at this point, even if we stopped the warming, or at least I should say for decades, even if we went to zero emissions, even if we could switch to 100% solar energy today, never burn another barrel of oil or lump of coal, it would take decades to stop the warming because of the lag times between heat in the ocean, melting ice, and sea level rising. So we have decades of sea level rise locked in already, and we won't reverse sea level rise for centuries. And if we don't stop the warming, we're going to melt the ice a lot quicker, obviously. So to summarize, and if you've got questions, I certainly encourage you to start thinking of what they are. If you're on Zoom, you can put them in the chat box. And if you're in the room there at Okamic, you can raise your hand and somebody will help you in a minute. But rising seas and shifting shorelines can be slowed, but can no longer be stopped. That's a sobering and maybe disturbing concept, but I do point out, to be fair, that 120,000 years ago, that sea level was 25 feet higher, even by nature. So we need to be honest and accurate in our depictions that this is not just caused by humans. Even without human effect, we should be planning for higher sea level. Each inch of higher sea level makes short-term flooding worse. In other words, when sea level is a foot higher and 5 feet of flooding from Hurricane Sandy or any hurricane comes to town, it's another foot, because sea level is the base height, and then the short-term flooding from storms, rainfall, runoff, or tides are additive, but those are temporary flooding. It's impossible to predict long-term sea level rise precisely for two reasons. We don't know how warm the world will be. We don't know how we're going to make our energy. There's arguments whether we should use nuclear power, which doesn't produce global warming, or whether we should burn all the tar sands, burn all the coal, or wait for some magical technology, nuclear fusion. So we can't predict exactly how warm the world will be. And even if we knew that, we still can't predict how 2 miles of ice is going to melt and collapse exactly. There's lots of models, but just like modeling the pandemic that we're all experienced with now, you can't model the future of most things that accurately, but you still want to try models to see what could happen. But they're not predictions, they're different projections, and there are different models. Vulnerable property values will be discounted before they go underwater. This is an important point that's new that I haven't said yet, that even if sea level is creeping upward at fractions of an inch a year and eventually will be inches a year, the effect on property values is not as obvious or simple as it might seem. When property goes underwater permanently, of course, it's worthless. But as sea level rises, it means that temporary flooding during those king tide events or storm tides or storm events will happen more often. So if your property floods more frequently, whether it be 2 days a year or 20 days a year, will affect its value. But if the water is getting higher and close to your property, even if your property doesn't flood yet, its value is being impacted because your neighbors and property appraisers and even these online services know that you're in a flood zone. And people are willing to pay a little bit less for your property if it has potential to flood. So I like to say that property values go underwater 3 ways. Permanently, when the land is submerged, when the property floods more often during the year, more days a year, but even 1 day is enough on a routine basis for people to say, oh, that property floods, I don't want to pay as much for that. But then even if your property is above the current flooding, but the flooding is getting higher and closer to your property, it has effect. And by the way, it's not just property on the coast. That's another big point of misinformation. Often the coastal barrier islands have high elevation, if you think about it. Often behind the beach or the A1A road going up the east coast of Florida can be quite high above the ocean. behind that, going westward, it can dip down into the intercoastal waterway or out toward the marshlands and the Everglades. So it's not necessarily the land right next to the ocean that's lowest. In fact, quite the opposite in most places in the southeastern United States. There's a coastal ridge or berm or ancient sand dune line that we actually now have houses built on and roads. And the lowland is further inland. And as you get out toward the Everglades or the marshlands, it's even lower. As sea level rises, it's going to get to those areas first. So it's not necessarily the lot that's closest to the sea. That might be 25 feet above sea level. I mean, there's many houses here that are like that. They're very valuable. In fact, some of the wealthiest houses. But then just on the western side, the land goes down near sea level, and often they have docks and waterfront homes there on the canals. So the recap of key points: sea level rise is unstoppable and somewhat unpredictable. Climate change will have many different impacts of higher temperature, changing weather patterns, melting ice, raising sea level, more flood rains in some places, and more droughts in others, more wildfires. Those are all effects of climate change. Disaster flood events are happening more often, and we need to assume that that's going to happen for a long time, even if we do the right things to get off fossil fuels and slow the warming. We should think of climate change as the impetus to do three things. One is to try and slow the warming by policies to get off fossil fuels and stop the carbon dioxide increase in the atmosphere. Two is we need to be more resilient for the kind of weather that we're seeing. It's not going to go back to normal anytime soon. And then we need to adapt for the future. And sea level is just the prime example. We can't get 3 feet of sea level rise this year. It's just, you can't melt that much ice that quickly. We might get a foot or two of sea level rise by mid-century. But the latest projections are by the end of the century, we can get between 2 to 7 feet of sea level rise, depending on how well we slow the warming. So we need to slow the warming. We need to be more resilient in our designs for what we can see in the near term. And we need to start adapting now for the long term. That's probably my strongest message. Energy efficiency is important. Renewable energies is very important. And in addition to all these climate change effects, we should tackle lots of other good green efforts, which are quite separate. Things like recycling or getting plastics out of the ocean, or being concerned about sea turtle nesting sites or manatee habitats, so there's lots of environmental and important issues, and we can subscribe and support many different issues. But what I pointed out at the start was, out of the large circle of environmental and green issues, climate change is a subset. And of that, sea level rise is a subset further. So if we're putting efforts and donations to nonprofit causes, I just ask that you make sure which effort you're supporting. You can support all of them, whether that be getting plastics out of the ocean, it's really important, whether it be encouraging recycling, that can be useful, although a lot of recycling doesn't do much good, frankly, unfortunately, but as a whole, I certainly encourage it, and I do it every day. And then encouraging policies to reduce the warming, to slow the rise in greenhouse gases, and in particular, to prepare for sea level rise, which is now unstoppable. To bring this down to final 2 recommendations that you might want to think about. One is evaluate your exposure, particularly to sea level rise. In my book, the current book, Moving to Higher Ground, there's a 18-point checklist at the back of the book, and just a different way to kind of think about different vulnerabilities and issues. Certainly encourage you to use that. And it'll even tell you how to download that as a PDF file and print it out. But the biggest thing that I hope you do is educate yourself, which you're doing today, and I applaud you for that, and teach others. That's something that everybody can do, whether you're 16 years old or 86 years old. You can educate others. I think you'll see that there's a lot of misunderstanding about this. I hope I've helped you see something more clearly today. I hope you've learned something. If you haven't learned something today, I guess that's great because it means you knew it all to start. But this is an important topic. I love teaching it. As Alice said, I get to teach this to groups all over the world, including professional groups like architects and engineers, military leaders, and the community here at Oak Hammock is the next to add to my list. If this seems overwhelming and depressing, I would just remind us all that we need to think about future generations. We really don't have a choice. We have to, I really believe we have an obligation, moral and practical and financial, to do, three things: to slow this warming and try and keep things to what we thought of as normal. But now with the information that there was climate change before, that sea level was higher before, to realize that even if we could stop the warming, that we should be planning for higher sea level. And that's a new awareness. I think you'll agree. Most people are confused. They think that if we get off fossil fuels and go to 100% renewables, that somehow magically sea level rise will stop. That's just not true. And similarly, that even if we could do that, and in 100 years that things stabilized, the fact is, even following the last ice age cycle, that sea level could be 25 feet higher. If you'd like my contact information, it's here. I have a website. As Alice mentioned, I have the Rising Seas Institute. It's our nonprofit. Alice has been a generous supporter of that, and I really do want to thank her for that. There's my Twitter, is at John Englander, if any of you are on Twitter and follow people. I'm also on LinkedIn. And then there's my book, which is in print, audio, and ebook. And so with that, I will stop the screen share. And thank you.
Just going to lead in with one question, John, and I appreciate your talk today very much, very clear. But I've been hearing a little bit about the Gulf Stream, which is very important to the weather patterns here in Florida. And I just wonder if you could comment on what you've heard about that.
Sure. The Gulf Stream is obviously a really important ocean current. It's been known for hundreds of years, and it starts in the Gulf of Mexico and comes up the east coast of Florida and crosses past Greenland and over to Europe. It helps with the heat balance and kind of allocation of heat on the planet, and it's been pretty stable for thousands of years. It is slowing down slightly, maybe about 15% so far. It's probably too early to tell for sure that it's caused by the warming planet, the melting ice, and climate change, but probably. In fact, I think it's safe to say that, but and there is some scientific proof now. The Gulf Stream is part of a larger current called the AMOC, the Atlantic Meridional Overturning Current. Looks like a giant twisted conveyor belt in the Atlantic. And so what happens, and the reason it's slowing, is that the surface warm water goes northward, and when it gets to about Greenland, it goes downward and becomes part of a cold water current that completes that conveyor belt. Well, as Greenland melts and dumps fresh water, which is lower density than the salt water of the ocean, in at the north end of that conveyor belt, it's slowing the driving force on the conveyor belt, if that makes sense. So it is a problem, but it's not going to stop anytime soon. I mean, there was a crazy movie, Day After Tomorrow, years ago, which described the Gulf Stream stopping in 3 days in New York under 20 feet of ice. That was not one of those nonsensical disaster movies. It can't stop anytime quickly. There should be some concern that over this century, if the warming continues and melting the Greenland ice sheet, what happens to it?
Thank you, John, very much.
Okay, let's start with our one that I see on Zoom. Michelle, if you'll unmute and ask your question, and then we'll go to our Oak Room here.
I just want to ask John if the icebergs that float down by Newfoundland are from Canada or from Greenland. Does he have any idea?
Generally, they're from Greenland. The Eastern Canada doesn't tend to have icebergs of nearly that size. So there is some ice, but like there was one was recently in the news off Newfoundland. Those, I mean, I don't know for 100% certainty, but the highest probability is that it's from Greenland, because Greenland has this 2-mile ice sheet, which Canada doesn't.
Okay, thank you.
Sure.
Someone here?
All right, a question here from our Oak Room.
I got a few minutes before my arrival in Mars.
Just go right to your question.
I want to talk about even here in Florida and in Gainesville particularly, we have flood zones. And
Yes.
I'm kind of curious about how those flood zones are defined, because they seem to be natural phenomenon, low spots in a high country. But do they need to be redefined in terms of this adventure upward of sea level rising, or are they okay as they are existingly defined? I mean, there are great large numbers of those in Gainesville.
Okay, so good question. There are flood zone maps that typically FEMA or the National Flood Insurance Program, part of Department of Homeland Security now, put out. They've recently been revised for many areas, both for better mapping technology, but also to account for rising sea level in coastal areas. Now in Gainesville, where you see flooding, of course, it's again not from sea level because you're 150 feet above sea level. I'm not familiar with that, the detail of Central Florida, but the reason to redraw flood maps there would be because of heavier rainfall. But the interesting thing is, while you might think that's a whole different subject, it is connected, and I perhaps didn't cover it clearly enough. As the oceans warm, they evaporate more. And so with more moisture in the air, it's going to come down as rain or snow, depending upon the temperature. And we're seeing a lot more of that from that Texas snowstorm last winter in February to deluge rain all over the world, not just in coastal areas. So flood maps do need to be redrawn, both in coastal areas to allow for accelerating sea level rise, but even in inland areas, because we're getting droughts and we're getting heavier rainfall, record rainfall, deluge rain. So yes, flood maps will need to be redrawn all over the world. The one last point on that is that the problem with most flood maps in relation to sea level rise, again, they're looking at the near term. They're saying, based upon what we see today, looking at 5 or 10 years, maybe 20 years, what should we anticipate? The problem is, as I pointed out earlier, the big rise in sea level won't happen for 10 or 20 years. So if you're designing a new house in the Florida Keys, just to take an extreme hypothetical example, or anywhere else in the world on the coast, and you wanted to design the house to be handed down to your grandkids or great grandkids, you should plan beyond the flood maps, to make it really simple, because the flood maps aren't trying to look out for 30 years. They tend to be looking at the floods that can happen, quote, now. And they might extend that to maybe a decade or so. But the problem is we build buildings and infrastructure that lasts typically 100 years. So that's why the flood maps are inadequate information. Next.
Yes, I've got a question. When I lived in South Florida, on occasion, I would have to go down to South Miami or Miami Beach, actually Miami Beach and Alton Road.
Yes,
And I don't know if you're familiar with that area, but
I am.
it used to be nice sunny days. I would go down there, and yet the roads, Alton Road would be flooded.
Yep.
And I know they were going to spend a lot of money on trying to fix that. And my first question is, have they done that? Have they been successful? Is Alton Road still flooding?
Yeah, no, great question. I've been there. I've got photographs of it, in fact. Alton Road was one of the low spots. There were dozens of them in Miami Beach and South Miami, as you say. Alton Road was a particularly bad spot where the road was low. The problem is sea level rise, and it would hit at full moon high tide, or following this 18.6-year tide cycle, which is very predictable. And it was getting worse and worse as sea level rose. The tides are, as I said earlier, on the base of higher sea level. And they have fixed it. They've spent hundreds of millions of dollars putting in pumps and raising roads and sidewalks. but they know that that's only buying them a few decades. That there's a limit to how far that can go. But yes, in fact, they put these huge pump boxes in, which some of the residents are complaining about, to put massive submerged pumps to pump the water out. But you've got to pump the water somewhere. And as the ocean rises, there's limits to how far that'll work. But yes, they have dealt with that for the short term.
Thank you. And my second question is, what role, if any, do you see the insurance industry playing in perhaps mitigating some of these factors?
Well, I don't want to get into too deep, but the simple answer, and it's in chapter 7 of my book about insurance. And if you're interested in this, it may be worth getting a copy of the book. And I'm not trying to hawk the book here, but to summarize it, the problem is that insurance is only done year to year. When you can't buy a 10-year flood policy, okay, even from the federal government. So if you think about it, the basis of insurance, whether it's, life insurance, you can buy term life insurance, but at a fixed rate, because there's a big enough database and we know the odds of you living to a certain age. So the insurance companies will do that. But there's no property and casualty insurance for 10 years, okay? And certainly none for 30 years. So the big problem in insurance is a mismatch of periods. We finance property for 30 years, like a typical home mortgage, and it requires that you have insurance, but nobody will tell you what the price of insurance will be beyond 2 or 3 years. So that's the fundamental problem with insurance. They're interested in this, and they talk about sea level rise. They're really interested in short-term flooding, with sea level rise just being a tiny, tiny factor so far.
All right, John, do you have time for 2 more questions?
Sure. Yeah, I'm good.
Thank you very much for a very, very interesting presentation. You mentioned ice in the water and also ice on the land, Greenland. Is there a difference in the terms of melting, in the terms of the dynamics of the ice in these two places, the land and the water?
Sure. In fact, and again, Greenland is similar to Antarctica in that the ice on land is, the ice is on land, okay, in Antarctica and Greenland. Around the North Pole, it tends to look similar, but in fact, you can see in this map behind me, you'll notice Greenland is white, and so is Antarctica. To the left of Greenland and above it is the North Pole. That's the Arctic Ocean. That's just ocean. And it has floating ice on it, as you'll recall that polar bear who was adrift on a big ice flow. So to answer your question, the ice on Greenland and Antarctica and in Alaska, some in Alaska and the Alps and so on, that's ice which as it melts will add to global sea level. The floating ice will not, for the reasons I explained, like ice cubes in a glass, but the ice that's floating will melt much quicker because it's surrounded by ocean, salt water, which has a lot more heat value than the air temperature. So you'll see the icebergs and ice shelves, which are kind of a hybrid where it's the ice from Antarctica that is resting on the water. They will melt faster than the ice on land. I hope that makes sense.
Okay, thank you very much. Very informative presentation.
Great.
The United States is trying to do their part to get away from fossil fuel. Is any attempt being made to bring the rest of the world on board, like India and China, who are the biggest users of fossil fuels?
Yeah, in fact, that's exactly what this conference that was in November, the 26th annual COP conference, the conference of the parties, negotiating how the different countries should try and get off fossil fuels. They always come up with lofty plans. And frankly, the US has been no better at slowing the warming than China and India. The argument is, can they get their basic economies going and provide power to people using the same technology that we did? And it's a political argument, and I'm not going to opine on it either way. I don't think the US doesn't have this, is not setting the standard. It's trying. California is doing better than the rest of the US, but there's great disagreement about how to price carbon dioxide emissions, basically, or fossil fuel emissions. China is making an effort, I would say that. Europe's making a good effort. Some countries like Germany and Japan are making a better effort. but there's 196 nations that need to sign on to this. And the problem is, and it's really worth making this point, whatever we do to slow the emissions is gets to the global picture. Whatever we do in Florida doesn't affect Florida. It's diluted with the effects globally. So we have to get into these global agreements where there are formulas to incentivize different countries to do this. And while the US is making some efforts, the US contributes the most warming, per person for sure. China and India do put out a little more warming because they've got 3 or 4 times the population we do. But on a per capita basis, we're still the worst emitters. I don't like to point fingers at anyone. We all have to do better. But sadly, every year that they've had these conferences, the discussions and formulas and pledges get better, but we're not making progress.
All right, one final question here. Marguerite?
Yeah, I feel like a very bad human being, but we listen to all these programs, but really it's the human being who creates all these problems in the long run. And shouldn't we control our population a little better around the world, not just in the United States?
Well, I think you could perhaps answer yes, but I don't think it makes you a bad human being. I think humans have had, as we exploit our technology and our intellect, we've done a number of things. I mean, that have damaged the planet. It's partly as a result of our perhaps insensitivity or not thinking through the effects, but it's partly basic population growth. As we've improved medical and practice and improved sanitation and antiseptics and all that, we now have 8 billion people. We're headed to 10 billion people. So one fundamental question is, what should we do about the population, which is, of course, controversial by itself. The degree to which we don't care about the environment, that probably is shameful. But I think the fundamental question of our role and responsibility and the ethics of what we do as human beings is a very complex issue, of course. I mean, obviously it is. And I don't want to say that if we were good human beings, this problem wouldn't exist. It's not that simple. So I think that there is a moral question here about trying to make the world better for future generations. I think that's very important. It applies to climate change, it applies to plastics in the ocean, it applies to overfishing, it applies to a lot of things. I think it's a fair question. There have been some great books over the years from Overshoot is one that came out 30 or 40 years ago that got into this topic deeply about where are we headed, to more recent books. And climate change just kind of makes it very clear. But I think our responsibility and opportunity as humans, is a really important topic. As I hope you see, I'm trying to be limited and practical in the basis to say, yes, let's work together to slow the warming. Groups like Citizens Climate Lobby, I name them in the book. They make an effort to get governments to put policies in place that will slow the warming, and I certainly encourage support of them. It's a complex problem. We need to work to slow it. We need to be more resilient, and we need to adapt for things like sea level rise, which can't be stopped at the current level.
John, we really appreciate your time. And it was a wonderful presentation. I think we all appreciate it. And thank you so much. Yeah.
No, thanks, Alex. And again, you've been a good supporter of my work, and particularly the Rising Seas Institute. And that's why I wanted to make a particular effort to, do this program for you and your community. So thank you. You've been very visionary and, responsible in terms of that support. And again, thank you very much.
Oh, you're very welcome, John. Your work is valuable, very valuable. Thanks again. Take the rest of the day off.
Okay. And I hope that, if people, please consider, getting the book, because you'll find that, as I think Alice is testament to, that obviously in this hour, I've only scratched the surface.
Exactly, exactly. Well, thanks again and do take care and give my best to Linda.
Thank you so much. Take care.